This is Artemis Mission Control. Clearly, what you have on your screen is a visualization. We are in a loss of signal with the Artemis II crew and the Orion spacecraft. This was a tracked LOS while we are on the Deep Space Network. We expect to regain communications shortly. In the meantime, the crew using some of their lunch break to photograph Earth and the moon outside of the cabin windows. This is Artemis Mission Control here at Johnson Space Center in Houston, Texas. Mission elapsed time of 2 days, 1 hour, 26 minutes of the flight of Artemis II. Our crew members aboard have wrapped up their midday meals. They are now moving into the CPR demo. This allows the crew to practice how they would practice CPR should they ever have the need aboard the Orion spacecraft. They will record this for the flight teams here on Earth to analyze and use as future training. You also just saw some movement on the camera. They were moving the solar array wings into the safe harbor position. This is what we do when we expect any movement inside the spacecraft, whether that be exercise or something like this CPR demo. We won't have inside views during the CPR demo.
Houston integrity in the blind. We are in 4100 coast default. 4 arrays are safe. Beginning the CPR demo now.
And if you heard that call from Commander Reed Wiseman, he says in the blind, not knowing whether we can hear them or not because we recently experienced a loss of signal or an LOS. Obviously, we did hear that call from the crew. This is Artemis Mission Control here at Johnson Space Center in Houston, Texas. The crew aboard Orion conducting their CPR demo, learning how they would offer CPR to a crew member in need if the need ever arose on the spacecraft. Of course, this is just a demonstration and will be used for future training for future flyers. Another consideration when we fly in space are solar eruptions. Between the Apollo 16 and 17 missions, the solar eruptions were a near miss for our lunar explorers. Today, those Apollo-era flares serve as a reminder of the threat of radiation exposure for astronauts in space, as well as technology. So understanding and predicting these solar eruptions is crucial for our safe exploration. We now have data, technology, and resources available that have improved, which enable advancements towards space weather forecasts and astronaut protection. These are all key to NASA's Artemis program to return human astronauts to the moon.
It's August 1972, and Ian Richardson, a future NASA scientist, is watching TV when the BBC announces
the interference is caused by solar activity.
He didn't know it then, but the sun had just erupted in one of the most powerful solar events ever recorded. There was no threat to humans because Earth's magnetic field deflects much of the sun's radiation. But the explosions were so powerful that intense radiation disrupted TV signals and caused radio blackouts. So what if you were outside Earth's magnetic field? On the moon and beyond, astronauts face the risk of extreme radiation exposure. Luckily, the intense radiation in 1972 occurred right between the Apollo 16 and 17 missions when no astronauts were in their path. As NASA plans missions to go back to the moon and then onto Mars, predicting the sun's activity to protect astronauts from space radiation is one of our biggest priorities.
One of the biggest unknown factors about going to space is the radiation hazard from the sun.
This is Ian today, studying the effects of the sun, also known as the field of heliophysics.
The sun is always emitting radiation like the light we see, but certain energetic particles, like from the August 1972 events, can be far more harmful.
To be able to forecast solar energetic particles, we need to know how the sun energizes them. The sun is made up of electrically charged particles called plasma. As this plasma moves, it builds up energy inside its massive magnetic field. This energy is usually released in two types of explosions. Flares are intense flashes of light. Coronal mass ejections are giant eruptions of solar material.
These solar eruptions send shock waves across the solar system, accelerating particles as they go.
These are solar energetic particles, or SEPs. They consist mainly of protons and possess a lot of energy that can affect satellite measurements and humans.
SEPs can bombard you with a lot of radiation in a short period of time. They can penetrate your skin, damage your DNA, and increase your chances of getting cancer and radiation sickness.
But they don't occur with every solar eruption. Only a small number of flares and coronal mass ejections create SEPs.
So we're trying to predict when SEPs form and how they travel through space.
At NASA's Goddard Space Flight Center, the Community Coordinated Modeling Center, or CCMC, is dedicated to testing prediction models. Working with global partners, they use data from NASA satellites at different vantage points and models to figure out how solar explosions behave, including how shock waves energize SEPs. And as we get better at predicting, we get more time to prepare.
Preparation for an SEP event, of which you may know that is already coming and perhaps the magnitude as well, the technique that you would want to use is to put as much mass between you and the source.
On the surface of the moon or Mars, astronauts can go underground or build shelter with local materials. But in transit, astronauts can only be protected with what's on the spacecraft.
Which means that you might have elements on a spacecraft that have multiple purposes.
NASA's space radiation specialists are testing different ways to do this. One strategy they tested on the Orion spacecraft involves crew members barricading themselves with as much mass as possible in the center of the spacecraft. Other possible techniques in development include vests that add mass and electrically charged surfaces that deflect particles.
In terms of radiation protection and radiation mitigation, the factor of time is extraordinarily important.
The sun has a natural 11-year cycle that transitions through low and high activity, which is indicated by the number of sunspots on the surface. More sunspots mean more eruptions, resulting in a higher risk for SEPs. But during this increased solar activity, the sun's magnetic field strengthens, enhancing its shield against another important source of radiation, galactic cosmic rays. These are charged particles traveling at nearly the speed of light that are thought to come from supernova explosions from within our galaxy and possibly further out in the universe. If solar energetic particles are intense sporadic storms, then galactic cosmic rays are a constant drizzle. Galactic cosmic rays are more sparse, but also much more energetic. They include heavier elements that can penetrate through vast amounts of materials. Understanding the rate of galactic cosmic rays helps us determine how much time astronauts can spend in space safely. To date, humans have only been on the lunar surface for a cumulative total of about 12 days. A trip to Mars will take 6 to 10 months each way. That means even more radiation exposure, and so NASA is doing work to prepare for that.
The moon is going to be a test bed for us in order to be able to prepare for Mars. The more that we understand the impact and the duration of radiation on the moon, the more we can extrapolate that to the length of time that we will be spending in transit and on the surface of Mars.
You're looking at a live view of the outside of the Orion spacecraft. Specifically in this frame, you can see the European Service Module and the Orbital Maneuvering Service engine. And in the video we just watched about deep space radiation, you saw some team members demonstrating how they could use cargo transfer bags to help protect a crew from radiation exposure. That is something that this crew will test out as well. On Flight Day 8, they have a radiation shelter demo timeline. During that time, the crew will build a makeshift radiation shelter within the cabin and prepare the lockers on the spacecraft for ingress. Of course, this is just a demonstration and practice in case it were to be needed for a future mission. Orion is currently traveling 3,246 miles per hour, 125,130 miles from Earth, and 144,220 miles away from the Moon. If you're just tuning in with us today, we were expecting to have the outbound trajectory correction burn this afternoon. However, that burn was canceled as it was deemed unnecessary following such a precise translunar injection burn yesterday. Teams confirmed we are on the proper trajectory to send us around the Moon and bring the crew home on Flight Day 10 with a splashdown in the Pacific Ocean. So they were able to cancel the outbound trajectory correction burn. And according to Christina Cook, the crew was able to enjoy a snow day. This is Artemis Mission Control at NASA's Johnson Space Center in Houston, Texas. The Orbit 1 team is currently on console, but you'll see a lot of activity happening in the room as the Orbit 2 team comes in to begin their shift. Of course, Mission Control is staffed 24/7 while in flight with Orion. And just down the hall, we have the International Space Station Flight Control Room, which has been staffed 24/7 now for over 25 years.
Integrity Houston, comm check, back with you on DSN.
We have you loud and clear.
Fantastic.
And Houston, we are complete with CPR demo if you want to get everything back to normal after that.
We copy. Thanks, Christina.
This is Artemis Mission Control here at Johnson Space Center in Houston, Texas. We have reestablished communications with the crew after an expected loss of communication through the Deep Space Network. We are now back in full communication with them. The crew reported they just completed their CPR demo. Again, just a practice of how they would execute CPR in the Orion cabin if need be. They were able to film this and will share it with the ground after their flight. And this view on your screen coming from a camera mounted on one of Orion's 4 solar arrays. Each solar array wing has its own camera, and this one is currently pointed back to see all of us on Earth. Wave hello, you look great today.
And Houston, we're just curious about toilet. Is it off, hands off right now?
Integrity, toilet is go for use.
Okay, integrity copies.
This live view inside Orion of the Artemis II crew.
Integrity feedback on your camera position. For your information, the top third of the flags is not visible. And now where you're placing the flags, I can see all of them. On the bottom part of the image, I can see about midway on Christina's calves, and I can see Victor's head and the camera to the in the right side of the field of view from the perspective of this camera. Copy, thumbs. Looks great. Christina is well centered in the frame.
This is Artemis Mission Control. Here at Johnson Space Center in Houston, Texas, the Orbit 1 team is handing over to the Orbit 2 team, now arriving on console. A live look inside Mission Control. We are now 2 days, 2 hours, and 35 minutes mission elapsed time since Orion launched atop the Space Launch System from Kennedy Space Center in Florida. Our Artemis II crew is well on their way to the moon, now 127,840 miles from Earth and continuing to grow as the distance to the moon shrinks, currently 142,294 miles away. This a live view from a camera on the solar array wing on Orion, looking back at the spacecraft, and over there on the right side of your screen, home sweet home, our planet Earth. Earlier today, we were expecting to conduct the outbound trajectory correction burn. However, because our translunar injection burn yesterday was so precise, that outbound trajectory correction burn today was canceled, considering it not needed. As the Orbit 1 and Orbit 2 teams hand over, I am also handing over the Public Affairs console to my friend and colleague, Anna Schneider. She'll be continuing our live coverage. Again, we're here 24/7 throughout the mission, all the way through splashdown and recovery of our astronauts.
Houston, Integrity, can you please verify toilet is available?
Integrity toilet is available. Go for use.
Thank you.
Integrity Houston, just wanting to let you know that we are going through our flight control room handover. I am bidding you farewell and appreciate getting the opportunity to support you thus far. And I'm leaving you in the amazing, capable hands of your favorite CTO. Have a good night.
Good night, Chris. It was a great day working with you, and safe travels. Enjoy training.
Integrity Houston, voice check on 1. We're setting up for S-band DFQ.
We missed that call. Houston, can you repeat?
Yeah, we were doing some setup in prep for the sat mode DFTO and needed to do a quick voice check, and we had you loud and clear.
We having the same, and I have 21.1.10 up on DU3 lower, and I am ready whenever you are. Please give us a call when you're ready.
And Victor, we copy you are ready for the DFTO. As we mentioned earlier, we'll delay it about 30 minutes from the start. So 20 minutes from now, you can expect a call up that we're ready to get going.
That sounds great. It's good to hear your voice, Jackie. How are we doing so far?
It's great to talk with you, and doing great. Keep it up.
Hey there, Jackie.
Hey, Jackie, it's so good to hear your voice.
Mojave.
Houston integrity for acoustic monitor question.
Go ahead for acoustic monitor.
Hey, Jackie, I am doing my activity for the DFTO of the toilet acoustic monitoring. It's from earlier today, and the acoustic monitor is acting strangely. The battery was not indicating low. It was a yellow outline with a green interior. However, the acoustic monitor turns itself off often. It's hard to get past even the first menu or into the recording. I think I'll go ahead and try changing out the batteries just in case, but I wanted to let you know in case you have any ideas.
Okay, Christina, we copy on the acoustic monitor. We agree that trying to change out the batteries is a good first step, and we'll think about whether we have any other advice in case that does not work.
Copy, thanks.
Houston integrity for AGA and exercise.
Go ahead.
Hey, Jackie, confirm you all are ready for Jeremy to start his exercise block.
Hey, great question. Thank you for checking. We still have a couple of things to configure before we're ready for active exercise.
Okay, if you're ready, I'll give you AGA readings, and then you can call us when it's time for exercise.
Send it.
Starter CO2 is 2.0, O2 19.7. Cabin pressure is 14.1, and temp is 76.1.
Houston copies.
Good evening from Mission Control Houston inside the Artemis Flight Control Room. I'm Anna Schneider with NASA Communications, and the Orbit 2 team of flight controllers has recently come on console and have completed their handover with the Orbit 1 team. The Orbit 2 team on console is being led by Flight Director Paul Kanya. And next to the flight director there on your screen, you can see the Capcom or capsule communicator, who is Jackie Mahaffey, and she is the individual that is communicating directly with the crew on board the Orion spacecraft as it makes its way to the moon as part of the Artemis II mission. Jackie Mahaffey also served as the Artemis II training lead, so she has worked pretty closely with both the crew and the flight control teams as they prepared for this Artemis II mission. We are now 2 days, 2 hours, and 54 minutes into the Artemis II mission, following a launch at 5:35 p.m. Central, 6:35 p.m. Eastern on April 1st. The Orion spacecraft, which was named Integrity by its crew, is currently about 128,000 miles away from Earth and has about 141,000 miles between it and the moon.
HHP views, Jeremy's about to start exercise. He's okay with that. Up to you, though.
We copied. Stand by.
And you just heard some communication there from NASA astronaut Reed Wiseman, who is the commander of the Orion spacecraft, down to the team here in Mission Control Houston. They have been discussing some upcoming exercise activities. So on the timeline, CSA, or Canadian Space Agency astronaut Jeremy Hansen, is scheduled to complete his daily exercise, and then Christina will complete her exercise as well. The crew uses a device known as the flywheel on board the Orion spacecraft to complete that exercise every day. While Christina and Jeremy complete their exercise, NASA astronaut Victor Glover is also scheduled to complete a SATBAN, or a search, acquire, and track, DFTO, or developmental flight test objective. And then a little bit later in the day, NASA astronaut Reed Wiseman and NASA astronaut Victor Glover will also complete some checkouts of medical devices. And then all 4 crew members will work to complete some pre-lunar flyby cabin configurations as they continue on into their day. And currently on your screen, you are seeing a look at the Artemis Real-Time Orbit website, or AROW, AROW. This website is available to the public at all times at nasa.gov/trackartemis. And we provide this view when we don't have live views from the Orion spacecraft itself, but using this view, you can see the real-time data and telemetry coming from the spacecraft.
Integrity Houston for timeline, big picture this afternoon.
Go ahead.
Hey, we are wrapping our arms around some of the different DFTOs, the maneuvers that they require, the solar array configs that they require, and the fact that we've shifted the S-band DFTO a little bit relative to the planned exercise. So bottom line, we are not going to go for any exercise prior to the S-band SAT mode DFTO. And during that DFTO itself, we go to VLDR, so we do not want the streaming setup from Orion integrity because we don't have the bandwidth for it. After S-band SAT mode DFTO, there will be a bit of a window to get exercise in, and then once we head into the EMERCOM DFTO and D5 camera imaging maneuvers, we will need to stand down from exercise again. How copy?
Copy all.
All right, and we still expect to pick up with SAT mode in 10 minutes.
Okay, we copy. Standing by for SAT plane mode DFTO in 10 minutes.
Integrity Houston for Victor and the SAT mode DFTO.
I'm with you, Jackie.
Hey, we are ready for you to get going in that procedure. One answer for you in step 5.2, instruction 68. The answer will be yes, you would like to do that type of maneuver.
Yeah, Jackie, I'm sorry. We're sharing PCDs up here, and so I currently don't have one. I'm operating off of DU3 only. But Weed has one and a pencil out now. Can you just repeat that whole transmission?
Yep, and I think this is one we should have comms, so we could also remind you right beforehand. But in instruction 68, the question is, will maneuver be a rotation around the biased tail to sun vector? And the answer is yes.
Okay, we copy. Thank you. Any other data I need before I get started with this procedure?
Nope, that's it, and we're ready for you to begin.
Copy and confirm you have step 1.
Concur, step 1 is complete, and we're ready for you in 2.
This is Artemis Mission Control in Houston, Texas. You have been hearing some communications between NASA astronaut Victor Glover, who is serving as the pilot on board the Orion spacecraft, and the Capcom or capsule communicator here in Mission Control, who is currently Jackie Mahaffey, which you can see there in the center of your screen. Victor is currently working through a SAT mode DFTO, or a search, acquire, and tracking mode developmental flight test objective. During this DFTO, Victor is working to reconfigure the S-band communication system on board the Orion spacecraft. The Orion S-band communication system provides functionality of 4 radios in one, and allows communication with multiple space vehicles, as well as NASA's Near Space Network, NASA's TDRS system, and the NASA's Deep Space Network. Currently, the Orion spacecraft is working off of the Deep Space Network.
Houston Integrity commanding S-band to SAT encrypted pointing mode.
Houston copies, we're ready.
Houston integrity and instruction 46. Ping, good. Baseband processor frame is locked. It was 2 minutes 45 seconds. Checking with you to proceed to step 4.
Houston, we have you loud and clear. We're ready for step 4. And Victor, could you read the instruction number of your step 4, please?
Step 4, titled Test 1, Testing SAT Mode Receive Link Recovery Capability, is instruction 43.
Okay, thanks. That is what we had. I think I misheard an earlier instruction call from you. Thanks.
That may have been just me telling you I was on the instruction that said to check with MCC, and that was a couple of instructions back. Houston integrity ready for receive link loss of signal.
Integrity, we copy from the ground. We will implement the loss of signal. You can expect a 5 to 10 minute LOS and expect you may see your antennas cycling through looking for the signal.
Copy all, and we're watching.
This is Artemis Mission Control in Houston, Texas. On board the Orion spacecraft named Integrity, NASA astronaut Victor Glover continues to work through the SAT mode DFTO, or the Search, Acquire, and Tracking Developmental Flight Test Objective. And he has been coordinating the steps and procedures between the team here in Mission Control Houston, namely the CAPCOM, or Capsule Communicator, who is currently Jackie Mahaffey. Of course, there's many other console positions here in Mission Control, but they all flow their information through the Capcom, and they serve as the single voice link. So for this particular developmental flight test objective, one of the main console positions working all of the objectives is the INCO position, and that stands for Instrumentation and Communication Officer, and they are responsible for managing the communication systems of the Orion vehicle, including the phased array antennas, baseband, signal processors, and audio systems. Working alongside the INCO console position for this developmental flight test objective is the GC, or Ground Control Officer. And that position manages the team that maintains and operates ground and network facilities, including voice systems, building systems, redundant power systems, and more. And there you're currently seeing a live look inside the Artemis Flight Control Room here in Mission Control Houston, and it's actually just down the hall in the same building as the International Space Station Flight Control Room, which is continuing to monitor the operations of the International Space Station and that crew. So currently there are 2 different NASA crews flying in space. Of course, the Orion spacecraft and its crew, comprised of NASA astronauts Reed Wiseman, Victor Glover, and Christina Cook, and CSA, or Canadian Space Agency astronaut Jeremy Hansen, on board the Orion spacecraft on its way to the moon. Yesterday, they completed the translunar injection burn, or TLI burn, which set it on its path towards the moon and back on a free return trajectory, and they are currently about 130,000 miles away from the Earth and about 140,000 miles away from the moon, so they're about halfway.
Houston Integrity, I am holding in instruction 59, checking with you to proceed to step 5. We are good and locked at about 2 minutes 30 seconds.
Victor, we have you loud and clear as well, and we are ready for you to proceed to step 5.
Copy, picking up step 5, instruction 62, test 2, testing sat mode, tracking through maneuver. request 107 to go to step 5.5.
Victor, we had you loud and a little choppy, but copied. You're ready to proceed to step 5.5, and we are ready.
Houston Integrity comm check.
Integrity Houston, we have you a little quiet, but clear.
Awesome, and that one, it was only, it went back to locked and ping good in just seconds. It was definitely not minutes.
Houston copies.
And Houston Integrity instruction 136, desire to exit sat mode early. How would you like me to answer that question?
Yep, we would like you to answer yes. We'll go ahead and try to buy back a little bit of time by not waiting for those bailouts.
You broke up right when you gave me the important data, yes or no?
Yes, yes.
Copy, exiting sat mode early. Houston Integrity, commanding SD pointing.
Houston copies. You're commanding S-band to GNC pointing.
Houston integrity sat pointing mode DFTO is complete.
Houston copies. We have a little cleanup from the ground, but that was an excellent test of that system. Things went very well. And we will work to get things in a config that supports exercise and let you know when that's the case.
This is Artemis Mission Control in Houston, Texas. We just heard some communications between NASA astronaut Victor Glover on board the Orion spacecraft and the Capcom or capsule communicator here in Mission Control, Jackie Mahaffey, as Victor was completing a developmental flight test objective for the SAT or search, acquire, and tracking pointing mode. And during this objective, Victor...
For a quick science observation.
Go ahead.
Hey, Jackie, while Ike was busy doing that DFTO, he inadvertently put the moon directly in the center of the docking hatch, and we took some long lens photos, and we can see all of Oriental and maybe even a bit of the annular ring. So we know we aren't in Earth orbit, low Earth orbit anymore.
Some faces just lit up at the science console, and we appreciate the call and look forward to the photos.
We'll put them in the PAO now, Linky. Thanks.
And Houston integrity, just finalizing the DFTO. Something that was not cleaned up in the procedure. Maybe it's a part of your ground cleanup, but we put seats 1 through 4 in listen on OE2. Just wanted to know if you're going to clean that up or if I should command them back to the way the procedure started.
Victor, we think seats 1 through 4 were in listen on OE2 to start with. Was that what you were asking about?
Hey, firm. Yeah, the procedure commanded them to listen. I actually don't remember what they started. I thought I saw them in something other than listen. I thought they were in off, but I'm not sure. If you're happy with them the way they're configured now, I will leave it alone.
Yep, we are happy with the current config. Thanks for checking.
Again, this is Artemis Mission Control in Houston, Texas. NASA astronaut Victor Glover just completed the SAT mode or search, acquire, and tracking pointing mode developmental flight test objective and was cleaning up some of the tasks associated with that activity. During that, we also heard a call down from NASA astronaut Reed Wiseman, who is the commander of the Orion spacecraft for the Artemis II mission. He noted that they were getting a good view of the moon, and he was able to capture some still imagery of that. So hopefully in the next day or so, we'll be able to see some of that imagery and share it with the world. The team here in Mission Control is also working to reconfigure some of the spacecraft so that CSA or Canadian Space Agency astronaut Jeremy Hansen can complete his scheduled daily exercise using the flywheel device.
Integrity Houston for Christina and acoustic monitor.
Go ahead. And also, before we start into that, can you verify toilets go?
Checking. Christina, toilet is go. We are okay giving you a blanket go for the toilet at this point. We will call you if we need you to have a period of stand down.
Okay, thank you. We copy that. And so does that mean we can disregard any no-use bans that are on Optimus? And I actually haven't checked Optimus, but we are going to completely go on the operating principle of we are good unless you have told us not?
Christina, affirm. You can ignore the toilet unavailable for wastewater dumps in the crew band, and we'll try to have a little better story for you tomorrow morning on the rationale and what the plan will be going forward. For acoustic monitor, we were checking on if the battery change helped, and if not, we had a couple other ideas.
Yes, Jackie, I was just waiting on that DFTO to be over to give you a call about it. Changed out the batteries, had the same issue, but kind of persisted, and what was happening was it was just turning off randomly at different times, but usually very early on in the record process, and never actually was successful recording. I continued to try, did a couple hard restarts, taking out batteries, putting them back, and eventually was able to get all 5 sample locations recorded. I did do them individually just to make sure that I got the 5 recordings and didn't lose them all if it shut down in the middle of one. Will that be okay?
Christina, that sounds great. Thank you for wrangling the batteries. And a little bit of intel we had was that sometimes those batteries do have difficulty seating. So maybe one of the swap outs helped a little. But if in future activities it continues to be a struggle, there is an option to power via the PCD. So just let us know.
Perfect. I had noticed that connector, and I was going to ask about that as well. At the time I put it away, it was acting pretty good. So maybe that battery reseat was the magic answer. Thanks for the insight, and I think we can call this one good.
Sounds great. Christina, one more follow-up on the acoustic monitor. When you recorded the toilet, did you do it by opening the lid or pulling the funnel off?
Funnel.
Houston copies.
This is Artemis Mission Control in Houston, Texas. We just heard some communication there between NASA astronaut Christina Cook, who is one of the mission specialists aboard the Orion spacecraft, and the Capcom or capsule communicator, which you can see there on the center of your screen, Jackie Mahaffey. Christina is currently working through another developmental flight test objective related to the toilet acoustics. So as part of this objective, they're collecting some acoustic or sound data related to the toilet on board the Orion spacecraft to evaluate the operational sound levels.
Integrity Houston, for exercise, arrays and ARS are configured. You are go for exercise. And let us know if you'd be willing for us to come on board.
Okay, Jackie. Yeah, you're welcome on board. We did go ahead and set up the Z9 for the T-shirt shroud activity, but I think we can put something back together for you.
Jeremy, for clarification, are you reporting that you completed the Z9 shroud build, or were you in the middle of it and would need to tear down to set up cameras?
No, it's just that I took down the HHP camera to use the articulating arm for the Z9, and I wasn't sure, that wasn't a pink activity, a flexible activity, so I wasn't sure if we were going to have something in that window during that period to test this out or not.
Jeremy, it was absolutely okay to set up the Z9 shroud early, and really it's just a spatial logistics check there, so we didn't need a particular target, and if you are happy with how you would set that up on the flyby day, then you are welcome to take whatever you need to set up other cameras.
Okay, understood. It's a little bit hard to test how effective the shroud is, and if the shroud gets in the way of the lens. That's a short lens, the 35 millimeter lens, and so until we have a target to take a picture or two of, it's going to be a bit tricky to know.
Houston copies.
And this is Artemis Mission Control in Houston, Texas. There is some communication there between CSA, or Canadian Space Agency, astronaut Jeremy Hansen and the Capcom, or capsule communicator, here in Mission Control, discussing a Z9 shroud. That was a timelined activity for the day, where Jeremy was assessing a makeshift shroud setup for the upcoming lunar flyby scheduled for flight day 6 to help capture better sunrise and sunset imagery and avoid some glares on the window. This is Artemis Mission Control. We're currently 2 days, 3 hours, and 52 minutes into the Artemis II mission, following a liftoff from NASA's Kennedy Space Center on April 1st at 5:35 p.m. Central, 6:35 p.m. Eastern. The crew has, of course, been capturing a ton of imagery during their mission, and this image there on your screen is a recent image that was uploaded and shared publicly. It was captured by the crew on the second flight day of the mission, and it shows the Orion spacecraft there in the foreground with the moon in its distance, and it was captured by a camera on the tip of one of its solar array wings, or SAW. And there are 4 cameras, one on each of the 4 solar arrays, that have been capturing imagery throughout, and they often provide our live views as well. So now, on flight day 3, the Orion spacecraft is about 139,000 miles away from the moon, so a little bit closer since yesterday, and it will continue to close in on that target, the moon, with the lunar flyby and closest approach being made on flight day 6.
Houston, please confirm good video.
Hey, we are going to do an ACU swap, and oh, we got good video, but just know we're going to lose voice for a minute while we do ACU swap.
And there on your screen, you're now seeing a live look inside the cabin of the Orion spacecraft. Again, that spacecraft was named Integrity by its crew. And so you can see a live look as the 4 crew members, NASA astronaut Reed Wiseman, Victor Glover, and Christina Cook, along with CSA, or Canadian Space Agency astronaut Jeremy Hansen, work through the remainder of their activities for their day as they are starting to round out flight day 3. On the left-hand side of your screen, you can see NASA astronaut Victor Glover there.
Integrity, Houston, voice check after ACU config.
Houston, we have you loud and clear after ACU swap.
Reed, we have you the same, and a little bit of clarification. It was not a swap. That was my mistake on words, but it was some reconfiguration after the DFTO.
And there you can see NASA astronaut Jeremy Hansen giving a thumbs up to the screen, acknowledging the words that just came up from Capcom capsule communicator Jackie Mahaffey here in the room, who you can see on the bottom right-hand corner of your screen. Also, in the live view inside the Orion spacecraft, you can see CSA, or Canadian Space Agency astronaut Jeremy Hansen as he sets up to complete his daily exercise using the flywheel device. The flywheels uses a series of pulleys along with a torque limiter, which is encased in a frame about the size of an extra large shoebox, which functions like a rowing machine. And so each of the crew members typically has a scheduled block of exercise time each day, and so Reed and Victor have already completed their exercise for the day, and then Jeremy and Christina will complete it now in the second half of the day.
And Houston, from integrity, just since it's been a while, the CO2 reading is 1.2 at the start of exercise.
Houston copies.
And this is Artemis Mission Control. There on your screen, you can see NASA astronaut Christina Koch floating into view and now disappearing out of view again. And then on the bottom right-hand corner of your screen, you can also see a view inside Mission Control here in Houston, and that is the Capcom console. And next to that is the flight director console. So the flight director for the Orbit 2 ship, which is currently on console, is Flight Director Paul Kanya. The Capcom or capsule communicator is Jackie Mahaffey. And then also joining Jackie on the Capcom console is NASA astronaut Tracy Dyson. There on the center of your screen, you can see Canadian Space Agency astronaut Jeremy Hansen as he uses the flywheel exercise device. To use this device, the crew places a strap between their feet, and then they pull on the strap, which allows them to perform different types of exercises, including aerobic, resistive, and rowing exercises. By strapping their feet against the footplate of the device, they can also use the bar to perform exercises such as bicep curls, bent over rows, and deadlifts. And then using a harness, the crew can also perform exercises such as squats and calf raises. Each of the crew members completes daily exercise, and it's an essential requirement for human spaceflight missions because without consistent exercise routines, the zero gravity environments can cause a reduction in muscle mass and bone density. Similar to the International Space Station, the crew there also completes daily exercise using different devices because they have a little bit more room to work with. So on the International Space Station, they have an ARED machine, which is a resistive exercise device, a treadmill type machine, as well as a bicycle that they rotate between depending on
the surgeon prescribed exercise routines for their missions. But here on the Orion spacecraft, they have the single exercise device known as the flywheel, which you see there, which can, of course, perform a variety of different exercises.
What was your flight number?
Integrity Houston, we are going to put in work a wastewater dump. Toilet is no-go. We'll take a thumbs up if you copy. Copy thumbs.
This is Artemis Mission Control in Houston, Texas. We are currently 2 days, 4 hours, and 23 minutes into the Artemis II mission, following a liftoff at 5:35 p.m. Central, 6:35 p.m. Eastern from NASA's Kennedy Space Center in Florida. The crew is currently awake and working through their timelined activities for the day. Canadian Space Agency, or CSA, astronaut Jeremy Hansen is currently completing his daily exercise. There's also some checkouts of medical devices taking place. And then earlier in the day, the crew also completed a CPR demonstration. And then originally planned for today was an outbound trajectory correction burn, but it was determined that that burn was no longer needed due to the accuracy of the TLI, or translunar injection burn, which took place yesterday, April 2nd. The next burn on this outbound journey to the moon is scheduled for flight day 4, and that will be the outbound trajectory correction 2 burn. Coming up, the crew will also complete some lunar cabin configurations, and then they will have a public affairs event before they have some private medical conferences, as well as a private conference with the flight director here in Mission Control, which is currently Paul Kanya leading the Orbit 2 team, and then they will get ready for their pre-sleep and sleep activities and then head into their sleep time. Currently on your screen, you can see a view of the Artemis Real-Time Orbit website, or ARROW. This website is available at nasa.gov/trackartemis, and you can continuously monitor Orion's data and telemetry on its way to the moon. So the Orion spacecraft is currently about 133,000 miles away from Earth and about 138,000 miles away from the moon, so about halfway between both.
Integrity on 1 for hygiene towel quantities.
Go ahead.
Hey, Jackie, can you confirm that we have 20 total, or do we have 5 total?
Checking. Integrity Houston, no action on the enabled ECLIS caution related to the wastewater dump, and we'll look at it from the ground.
Copy that.
This is Artemis Mission Control. You're currently seeing a live look again inside the Orion spacecraft. In the center of the screen is NASA astronaut Christina Cook, who is serving as one of the 2 mission specialists on the Artemis II mission. She's currently completing her planned daily exercise using the flywheel exercise device, which operates similar to a rowing machine but can complete different types of exercises, including resistive and aerobic exercises. Integrity Houston for a hygiene towel answer.
Go ahead.
There are, in fact, 20 total towels on board. You can find more in Locker Echo, Purple Bag 15, and they are hiding inside unused fecal canisters.
Okay, outstanding. Thanks, Jackie.
And you just heard some communication there between the Capcom or capsule communicator here, Mission Control Jackie Mahaffey, and the crew on board the Orion spacecraft as they were working to track down or count some hygiene towels. Here in Mission Control, the console responsible for some of those items is known as IVA, or the Intravehicular Activity Console, and they are responsible for supporting the astronauts and their activities inside the Orion spacecraft. And this flight controller monitors the crew's well-being, and they also provide suit support, hygiene, and internal crew support tasks throughout the mission.
Houston integrity timeline question for lunar cabin config.
Go ahead.
Hey, with the delays to exercise, curious if you have thoughts on how we handle the pre-lunar flyby cabin config, or we can make a suggestion if you need one.
Hey, Victor, we'd like to hear your suggestion. We've been talking a little bit about the timeline and priorities for the rest of the day, and we know it's going to be a squeeze. What you thinking?
We'd like to finish the exercise and delay starting that cabin config, if that's okay with the science team.
And Victor, when you say delay, do you have a time estimate for us? We're just looking ahead at some of the blue box activities and thinking ahead to the rest of the shuffle.
Yeah, we were thinking 10 minutes, but that's why if you have a recommendation, we will take your recommendation.
Integrity Houston, for timeline, we are okay with sliding the lunar flyby cabin config about 10 minutes to the right. We do want to aim to give you that full duration of that activity, but we'd like it to be complete by the start of the DSN EMERCOM DFTO. It's going to be most useful to do that activity together.
Yep, that's what we were planning, and then if we need to throw a couple of minutes into lunar flyby cabin config later, we might call you back about doing that too. But okay, we'll slide it to the right 10 minutes, and we'll be done by DSN EMERCOM checkout.
Sounds like a plan.
This is Artemis Mission Control. There on the far left hand of your screen, you can see NASA astronaut Victor Glover, who has been communicating directly with Mission Control here in Houston regarding some of their timelined activities for the remainder of the day. Namely, they've been discussing an upcoming lunar flyby cabin configuration.
A couple more pieces of data for you on the timeline shuffle. The avatar photo and toilet maintenance are flexible, so we don't have a concern with you pushing into that time. You could pull the avatar forward. The second person does not necessarily have to be Christina. Copy, Tom.
And they were discussing moving the lunar flyby cabin configuration. During this particular activity, the crew will develop and document an ideal configuration of the Orion spacecraft internal cabin for the lunar flyby observation period, which will take place on flight day 6. And they will deploy various cameras and equipment that will be used during the flyby, and also work to adjust the spacecraft's lighting and positioning of each crew member to ensure once they make it to that flyby on flight day 6 that everything is well set up and thought out and placed, so that they don't have to worry about trying to figure out where all those cameras and equipment will be going on that actual flight day itself. There was also mention of some activities related to Avatar, and this refers to a science investigation flying on Artemis II. Avatar stands for a Virtual Astronaut Tissue Analog Response, and it is an investigation that is using organ-on-a-chip devices, or organ chips, to study the effects of increased radiation and microgravity on human health.
Houston Integrity for AGA.
We're ready.
CO2 is 1.1. Do you need anything else?
Hey, Christina, we copy CO2, and we will take the other main constituents there.
Okay, everything is off scale low. Otherwise, oxygen 19.7, pressure 14.05, temperature 75.7 Fahrenheit.
Christina, we copy, and just a follow-up on that, we are pretty interested in keeping tabs on the temperature, so that's why we'll continue to ask for that full suite. And also, the wastewater dump is complete, and toilet is go.
Copy all. Yeah, thanks for that clarification. We were wondering, since you mentioned temperature, I did want to clarify that the side of the vehicle that AGA is on is much warmer than the other side where the vents are, the diffusers are. So just mentioning for your awareness that we feel that temperature isn't necessarily consistent across the vehicle.
All right, Christina, thank you for that insight. That is really helpful.
This is Artemis Mission Control in Houston, Texas. We just heard some communication there between NASA astronaut Christina Cook, currently on board the Orion spacecraft, and also seen there in the center of your screen. She just wrapped up some of her daily exercises in the flywheel device, and then she was also calling down to the Capcom or capsule communicator here in Mission Control to provide an update on some AGA or anomaly gas analyzer readings. And these readings are provided periodically throughout the day, and they are monitored and tracked by the EECOM, which stands for Emergency Environmental and Consumables Manager here in Mission Control, and they are responsible for the internal thermal control systems, air and water supply, and purification systems. And the equivalent to that position in the International Space Station Flight Control Room just down the hall is Ethos. They were also talking about some wastewater dump, the Universal Waste Management System, or basically the space toilet on the Orion spacecraft. And the space toilet, or the Universal Waste Management System, typically dumps that wastewater every day overboard. It's vented overboard, much like what happened during the space shuttle era. Now the crew is going to start working on their pre-lunar flyby cabin configuration activity, so they're going to be deploying some cameras and other equipment that they plan to use during the flyby on flight day 6 to just ensure that they know where everything should be set up, where it should go, and where each crew member should be stationed for that observation period. And we're currently about 2 days, 4 hours, and 51 minutes into the Artemis II mission. The Orion spacecraft carrying the 4 crew members who you currently see on your screen are about 134,000 miles away from Earth, and they have about 137,000 miles between them and the moon. So pretty soon they will actually be closer to the moon than they are to Earth, and we do expect them to pass that milestone in about 31 minutes.
Houston, integrity on 1 for lunar flyby setup.
Go ahead.
If you still have the HHP, we're wondering, in Jeremy's position, if he's looking out the window there, will the moon be right side up or upside down?
We have a great view. We'll checking.
Alternatively, is the north pole of the moon going to be in the vehicle plus X direction?
Yeah, we're going to go with the first way you worded the question and say affirm it's upside down in the position Jeremy is in right now.
So if he flips over, it'll be right side up.
That's how it works.
This is Artemis Mission Control. We are currently 2 days, 5 hours, and 3 minutes into the Artemis II mission. Currently on your screen, you're seeing a live look inside the Orion spacecraft, which is named Integrity, and it was named Integrity by its crew. The crew is currently working through a pre-lunar flyby cabin configuration activity. All 4 of them are working to deploy various cameras and equipment that will be used during the flyby, which is planned for flight day 6 of the mission. They'll also be adjusting the spacecraft's lighting and positioning of each crew member to ensure that all of the equipment, cameras, as well as the individual placement of each of them works and will be seamless during the flyby observation period. After this cabin configuration activity is complete, NASA astronaut Christina Cook, who you currently see on the left-hand side of your screen, will then work on a Deep Space Network Emergency Communications DFTO, or Developmental Flight Test Objective, and during this test objective, Christina will conduct a checkout of the emergency communications system while connected to the Deep Space Network. The Deep Space Network, or DSN, is NASA's international array of giant radio antennas that support interplanetary spacecraft missions, plus a few that orbit Earth, and it provides radar and radio astronomy observations that can improve our understanding of the solar system and the larger universe. And there you can see on your screen that the crew just turned out the lights on the Orion spacecraft. So now it's quite dark. And again, they are adjusting the lighting as part of that lunar flyby cabin configuration activity so that they can test the lighting as well as all of the camera equipment that will be used during the lunar flyby. And there on your screen now you can see an exterior view of the Orion spacecraft, and this view is coming to you from one of the solar array wing or SAW cameras on the Orion spacecraft. The Orion spacecraft has 4 solar array wings, and each of those wings has its own camera that provides various views throughout the mission.
Houston Integrity, just one note for PCDs. We're going to need to route power cable since we're down to 3 PCDs, so just keep that as a tracking item that we're going to need to do in the next day.
Houston copies.
This is Artemis Mission Control. You just heard some communication related to a PCD. That stands for Portable Computing Devices, which are basically the tablets that each of the crew members uses to track their timeline and other various activities throughout the mission.
Integrity Houston, we know you're having some important conversations there. I wanted to let you know we're a couple minutes from the official start of the EMERCOM DFTO, but we could probably push that by 5 minutes or maybe up to 10 if you need it.
Okay, copy. I think we're wrapping this up now. I think we've learned a lot.
This is Artemis Mission Control. You're once again seeing a live look inside the cabin of the Orion spacecraft. There in the center of your screen is NASA astronaut Christina Cook, and to the left is NASA astronaut Victor Glover. The crew is currently wrapping up a pre-lunar flyby cabin configuration activity, and during that activity they deployed several cameras and other equipment that will be used during the lunar flyby, which is planned for flight day 6. And they also adjusted the spacecraft's lighting and the positioning of each crew member. Following this activity, NASA astronaut Christina Cook will complete a Deep Space Network Emergency Communications Developmental Flight Test Objective, which will basically be a checkout of the emergency communication system on board the Orion spacecraft while connected to the Deep Space Network, which is an array of giant radio antennas that support interplanetary spacecraft missions. In addition to that activity, NASA astronaut Reed Wiseman and Victor Glover will also finish completing some checkouts of medical devices on board the Orion spacecraft. They did complete some of these checkouts earlier in the day, so they just need to wrap out a few final checkouts for that activity.
Integrity Houston, before we start the EMERCOM DFTO, we have a couple of timeline sync-up items to get you continuing on with the timeline while that DFTO is happening.
Go ahead.
Hey, Christina, for the avatar photo, while you are doing the historical photos, we'd also like you to take note of the lights, and if and when we've got either the EMERCOM or afterwards, just call down a quick light status for us. We didn't catch one this morning. And then second, I think we'd be interested in status on if folks got to the med device checkout at all yet. And with the trouble with the ECG this morning, we have uplinked message 3.03.06, ECG troubleshooting, and we would like that prioritized ahead of any remaining medical device checkout.
Okay, we can catch you up on some things. Medical device checkout is complete. Avatar photos are complete. For the avatar lights, they are all on, except for number 15.
We copy. And in that case, then the only other thing we'd be looking for is that message 3.3.6.
And POIC integrity for the avatar photos, those were taken about 2 hours ago.
Integrity Huntsville, we copy about 2 hours ago. Thanks so much.
And this is Artemis Mission Control here in Houston, Texas. There was some communication there between NASA astronaut Christina Cook and the Capcom or capsule communicator here on the ground, discussing some of the remainder of the activities for the day. And so Christina will be supporting a Deep Space Network emergency communications test.
Integrity Houston, our team on the ground is ready to step into the emergency comm DFTO when you are. And for your information, a few minutes ago, we put in a EPS cross tie just to cover us for some of the different attitudes we'll be in for the next couple of hours.
Copy. EPS cross tie is in for a couple hours, and I'm starting the EMERCOM DFTO now.
Copy. And Christina, I've got a couple of notes for you on the procedure when you're ready to copy.
Ready for your notes.
All right, a couple of nominal things to give you in the procedure itself. In instruction 15.1.5, you will want antenna 3. And in instruction 17.1.7, the answer is yes, we do want an attitude maneuver.
Copy all.
And then, Christina, the final item is we are going to transition directly from this activity into the next attitude for the D5 camera checkout. So if when you get to step 11, to maneuver to bias tail to sun attitude, assuming that we have good comm with you, the ground is going to take the attitude commanding to that camera window attitude. If for some reason you have not reestablished comm with us, then we would like you to perform step 11.
Copy. I will stop in step 11 and talk with you if we have comm. Otherwise, I will continue the procedure as written.
Good, readback. And we are ready for you in step 2.
Copy. Skipping to step 2.
And this is Artemis Mission Control. NASA astronaut Christina Cook is currently working through the Deep Space Network Emergency Communications Developmental Flight Test Objective, during which she's basically conducting a checkout of that emergency communication system on Orion while connected to that Deep Space Network. And coming up in just a few moments, we will hit an important milestone in which the Orion spacecraft will officially be closer to the moon than from Earth.
And Integrity Houston, we have some news to share with you. As of 30 seconds ago, you are now closer to the moon than you are to us on Earth.
Wow, Jackie, thank you for sharing that with us. We all kind of had a collective, I guess, expression of joy at that. It's hard to imagine, but we can see here on our flight PFD that we are at 118,000 nautical miles. So, yeah, you can do the math. We can see the moon out of the docking hatch right now. It is a beautiful sight. We're seeing more and more of the far side, and it's just a thrill to be here.
Houston copies.
And there we just had that confirmation called up to the crew that the Orion spacecraft named Integrity and its crew, which you can currently see on your screen, are now officially closer to the moon than they are to Earth. This comes about 2 days, 5 hours, and 24 minutes following a liftoff from NASA's Kennedy Space Center on April 1st at 5:35 p.m. Central, 6:35 p.m. Eastern. Now, while they are officially closer to the moon than they are to Earth, they have not entered what is known as the lunar sphere of influence yet. That milestone will come on flight day 5. And when that milestone happens, that is when the moon, instead of the Earth, becomes the main gravitational force acting on the Orion spacecraft. And we're currently in an expected loss of signal. So right now you're seeing a live look inside the Artemis flight control room here in Mission Control Houston.
And Houston Integrity on 1 for toilet and that kind of burning odor smell that we were reporting on the ground.
Integrity Houston, we're having a little bit of a choppy comm. Can you repeat?
Yeah, Jackie, we just wanted to sync up with you. We know that there was some talk about some burnt smell from the heaters. Just stand by 1. Okay, Jackie, so this time we turned on the WHC on the toilet and it had that burning odor smell that we just hadn't experienced before. And so we just wanted to talk to you about it. We know we had a briefing on that.
Checking. Hey, Jeremy, on the toilet, we're actually scratching our heads a little bit down here tonight on the odor that you are referencing. So can you give us a little more clarity on it happened when it was running or not, and this is the first time that you have experienced it? Is that correct?
So the crew has smelt it once or twice before, but this time was stronger and was different. And we opened the door, everybody in the cabin could smell it. So we just thought we'd check in with you. We're not overly concerned right now. It's probably related to what we're told to expect, but we just wanted to have a quick conversation.
Jeremy, we're checking. Integrity Houston, we are pulling together the minds here to recall exactly what the pre-flight expectations were. In the meantime, we would like a quick AGA reading from its location.
And Jackie, all AGA readings are off scale low.
Houston copies. Thanks.
Jackie, for the EMERCOM DFTO, I am ready for your go in instruction 76. I understand we might be pausing to address this issue. And regarding the smell, I just wanted to be sure you all were tracking the EGS notes of the kind of burning heater smell that was coming from toilet several times. It was never identified as a source, what it exactly was, but it was identified as a known smell. So that's one reason why when I smelled it earlier, I didn't report it. It was kind of a lighter odor than this time, though.
Copy all, Christina, and yeah, we'll discuss at least for a few minutes here before we continue on with the EMERCOM DFTO. And yep, we are getting the information about the pre-flight smell now, so thanks. Integrity Houston on Orion to Earth 1 for the toilet. We've discussed, based on the pre-flight reports and the AGA readings, we're going to continue discussing on the ground, but we are comfortable continuing with the emergency comm DFTO, and we are comfortable with you continuing to use the toilet.
Okay, understood, Jackie. No, that sounds reasonable to us.
Okay, and the final thing, we'll lose video during the EMERCOM DFTO, but just in case you're still working on ECG checkout when we get back, just please be mindful of screens being viewed by the HHP camera.
We copy, and with that, do I understand I have a go in instruction 76?
Christina, A-firm, you are go in 76, and when you unpower S-band, expect a caution, pry S-band fail.
Copy.
This is Artemis Mission Control here in Houston, Texas. There was quite a bit of communication between the crew currently on board the Orion spacecraft, who you can see there on your screen, and the ground, namely the Capcom or capsule communicator position. They were discussing some odors, possibly related to the toilet system and some motors. And then they were also discussing resuming the Deep Space Network Emergency Communications Development Flight Test objectives. So Christina continues to work on that. And then Reed and Victor have been wrapping up some medical device checkouts, including a checkout of an electrocardiogram or ECG device. And right now we're in an expected loss of signal. So you're seeing a live look inside the Artemis flight control room here in Mission Control Houston. And this flight control room is just down the hallway from the International Space Station flight control room. And currently on console is the Orbit 2 team of flight controllers. And during the mission, there are 3 shifts, which are known as orbits, that monitor the crew and its systems 24/7. The Orbit 2 team of flight controllers is being led by NASA Flight Director Paul Kanya, who you can see there on the upper right-hand side of your screen, and he is sitting next to the Capcom or capsule communicator for this shift, who is Jackie Mahaffey there in the center of your screen, and next to her is NASA astronaut Tracy Dyson, also sitting at the Capcom console. Coming up on the timeline, NASA astronaut Victor Glover is expected to complete a window optical quality developmental flight test objective. And during this objective, Victor will take out a D5 camera and take some images at different focal lengths of various subjects out of the windows, such as the Earth or Moon, to evaluate the optical effects of the windows on the Orion spacecraft on imagery. And then currently on your screen, you're seeing a view of the Artemis Real-Time Orbital website, which is available at nasa.gov/trackartemis. And this provides view of live data and telemetry coming from the Orion spacecraft, especially when we don't have the live views of the Orion spacecraft itself. And just a few minutes ago, the Orion spacecraft and its crew did surpass a milestone, of which they are now closer to the moon than they are to Earth. So you can see there in the bottom right-hand side of your screen that the Orion spacecraft is currently 137,000 miles away from Earth and about 135,000 miles away from the moon. This is Artemis Mission Control in Houston, Texas. You're currently seeing a view of the Artemis real-time orbit website on the left-hand side of your screen, which provides live real-time data and telemetry from the Orion spacecraft when we don't have live views from the spacecraft itself. We are currently in an expected loss of signal. And then in the bottom right-hand side of your screen is a look inside of the Artemis flight control room here in Mission Control Houston. Currently on console is the Orbit 2 team of flight controllers being led by Flight Director Paul Kanya, who is in the upper right-hand side of that screen. On board the Orion spacecraft, the crew is currently awake. They are wrapping up some final activities for the day. NASA astronaut Christina Cook is currently working through a Deep Space Network Emergency Communications Developmental Flight Test Objective. Victor is also working on a test objective related to the D5 camera imaging and taking some images at varying focal lengths of subjects such as the Earth and the Moon to evaluate the window optical effects on imagery. And then NASA astronaut Reed Wiseman is working to transfer some data from the flywheel, which is the exercise device on board the Orion spacecraft. And then coming up here in a little bit, CSA, or Canadian Space Agency astronaut Jeremy Hansen, will support a public affairs downlink event for the Canadian Space Agency. We are currently 2 days, 6 hours, and 1 minute into the mission, following a liftoff at 5:35 p.m. Central, 6:35 p.m. Eastern on April 1st. And the Orion spacecraft did recently pass a milestone where the crew and the spacecraft are now closer to the moon than they are to Earth. As of right now, they are about 138,000 miles away from the Earth and almost 134,000 miles away from the moon.
Houston integrity in instruction 10 of S-band string swap. I have a frame lock, but ping is still suspect. Perhaps that's because we are going to be receive only here. Let me know if I can continue. And Houston integrity disregard. I now have a good ping as well. I have you loud and clear on EMERCOM.
And integrity Houston, voice check, I'm coming up on regular OE1.
Also loud and clear on OE1. Actually, both radios sound very close to each other. No big difference between either.
All right, great news. And Christina, with that, we are go for you to begin step 10.
In work. And Jackie, I am in step 11 where you told me to give you a call, and I do have one question about EMERCOM.
We'll take your question.
Okay, not to hold you up, just for understanding, I noticed I had a timer going for about 45 minutes there since we started the ranging. I seem to recall a 45-minute limit for temperatures in TX, RX mode. I was just curious, one, if that's good memory, and two, if we saw temperatures starting to get to their exceedances. And I can take that answer later.
And Houston integrity, just wanted to check with you. I assume we can't do the PAO test until Christina's done.
Jeremy, we are in a good config to start the PAO test.
Okay, I'll start it now.
Integrity Houston, the attitude maneuver to the docking window attitude is impending.
Copy, thanks. Jackie, can I go ahead and close the EMERCOM procedure and consider that complete on my end?
A-Firm Christina, we are ready for you to be done with EMERCOM DFTO.
Copy.
And Jeremy, we have good video again, and we're ready for a scene and voice check when you are. Hey, Jeremy, you look great, but we did not hear that audio via the microphone. Jeremy, we like that scene and voice. Jeremy, we expect to be ready for an on-time start.
This is Artemis Mission Control here in Houston, Texas. We are currently 2 days, 6 hours, and 31 minutes into the Artemis II mission. Currently, you can see CSA, or Canadian Space Agency astronaut Jeremy Hansen, as he gets set up for a CSA Public Affairs downlink event, which will be taking place here in about 3 minutes. And that downlink event will air live to the public as we continue to provide our 24/7 continuous coverage of the Artemis II mission around the moon and back.
Integrity, this is Houston. Are you ready for the event?
Houston, Integrity is ready for the event.
Canadian Space Agency, this is Mission Control Houston. Please call Integrity for a voice check.
Integrity, this is the Canadian Space Agency. Do you hear me?
We hear you loud and clear. We're a long ways away. There's probably a bit of a delay, but great to chat with you. I got a few people joining me today. I got Victor and Reed here. Christina's working hard right behind the camera right now.
Hello, Jeremy. It's Lisa. Hi there, Jeremy Hansen. It's Genevieve Boschman from CTV News here on Earth. Great to talk to you en route to the moon. We saw those great images, that great image of the Earth today. I wonder if you can describe for us, though, and for so many Canadians who are following your mission, what you're seeing with your own eyes that really those cameras really can't quite capture, what that's like for you, and as you prepare for that flyby, what you want Canadians to take away from what they're going to be seeing and what you're going to be seeing.
Well, first off, hello to you too, Lisa. As far as the images go, we see those exact things, but the difference for us is just how we see them and like how much of the window they take up. And so, gosh, in our first day in space, we just saw some extraordinary things. The Earth up close, and then by the time we had a bit of a nap and got up, the Earth was just so far away again. And then to come in for that translunar injection, we came all the way back to Earth again. We were out there at 60,000 kilometers. We came back to within 200 kilometers of the planet. And it just felt like we were falling out of the sky back to Earth. And I said to Reed, it feels like we're going to hit it. It's amazing that we're actually going to go around and miss this thing. It was just so close. And so to take all of that in was really phenomenal. I don't know. What do you think, Reed? Yeah.
Jeremy said, you just said it so well, and it's so fun to watch you as a first-time flyer up here running circles around all of us. You're doing a great job. But going from 38,000 miles above the Earth yesterday down to 100 miles above the Earth, and then Christina and Jeremy did our translunar injection just 100 miles off the surface of the planet. We were screaming right above the clouds, and now here we are well over 100,000 miles away from Earth and closer to the moon than we are to the Earth right now.
Bonjour, Camille Cassici-Monet de Radio-Canada. Une question en français maintenant. Je voulais savoir, M. Hansen, qu'est-ce qui vous a le plus surpris, le plus marqué depuis que vous avez quitté la planète Terre, depuis que vous êtes dans l'espace?
The most awe-inspiring thing for me, pour moi, il y avait trop de choses, mais d'être sur la fusée et toutes les sensations de la fusée, c'était quelque chose d'incroyable. J'ai eu le sens d'être un enfant encore et bien sûr la vue que j'ai parlé de la Terre et aussi la Lune. Les choses changent avec la Terre aussi. On voit pour nous, ici, dans la capsule, c'est comme la Lune et les phases de la Lune, mais c'est la Terre. Et c'est juste quelque chose d'extrêmement extraordinaire pour nous ici. So some of the things that are riding the rocket for us has just been extraordinary, and we have all these simulations, but it felt so different for us in real life. And then the views of the Earth and the crescent Earth is really incredible.
Hi, Jeremy. This is Ivan Semenik from the Globe and Mail. Congratulations to you and Reed and Victor and Christina for everything you've achieved. The pictures look great. I wanted to turn the view around, and maybe you can tell us a little bit about what you're seeing of the moon already. Is it looking bigger to you? And how are you planning to observe? I know you're only going to have a partly illuminated far side. What are you planning to focus on when you're around the back side of the moon?
So very interesting that we've taken some pictures. We are now over the halfway point to the moon, and we took some pictures earlier today. And then after putting them on the computer to look closer, we found a feature, you know, the Grand Canyon of the moon. It's called Oriental Basin, and we were able to see the entire thing. Stand by. We were able to see the entire thing, and so it's clear that we are not on Earth because that feature is not all visible from Earth. And so it's already special, the view that we have. And yes, the Earth is quite small and the moon is definitely getting bigger.
And as far as things we're looking forward to seeing, of course, you know, seeing Oriental on the far side of the moon, of course, up close would be extraordinary. But on this, because of this launch date, something that the scientists have added for us is we're going to see an eclipse of the sun behind the moon, which would be pretty neat, actually. And we can use that opportunity to look for some of the lunar regolith lofting, etc. So that's something that we hadn't been thinking we were going to be able to do, but because we launched on April 1st, the birthday of the Royal Canadian Air Force, I'll just add in there, we're going to get to see that now, which is pretty neat. And I love the fact that science just is like, okay, well, that's what we're going to have now, and here's what you're going to do. And it was really cool to see that all come together.
Bonjour Monsieur Hanson. Alors question à ça encore une fois, il y a beaucoup de jeunes Québécois, de jeunes Canadiens qui vous regardent aujourd'hui. Qu'est-ce que vous aimeriez dire à tous ces enfants qui vous regardent et qui sont inspirés de vous voir aller?
What's important to share with youth that are interested in pursuing their dreams, maybe flying in space? Pour moi, une chose qui est vraiment importante, c'est de trouver vos passions et suivez ces passions, mais aussi partagez-les avec les autres. Parce que pour faire des grandes choses, comme nous ici dans cette capsule, pour aller vers la Lune, survoler la Lune, ça prend une grande équipe. Et c'est la même chose pour chacun dans nos vies. On a besoin d'une équipe avec nous pour nous aider. Alors partagez vos rêves avec les autres. Vos parents, professeurs, et vous allez voir que les autres vont vous aider beaucoup. So for me, when I look back, I didn't do anything by myself in life. I did it with a team around me. And so it's important that you find what you're passionate about, but you share those passions with others, because you're going to find that they're going to help you to achieve them. And that's exactly what's happening for the four of us in this capsule right now. We're out here 200,000 kilometers from Earth, over that now, because of a big team back home on Earth.
Hi, Elizabeth Howell from Space Q. Congratulations to the four of you. And I was noticing that there's a Canadian actor, Ryan Gosling, who happens to be playing an astronaut in a new movie right now, Project Hail Mary. And Ryan also recorded a video for the entire crew, sending you best wishes. And so if Ryan happened to be there, asking you this in real time, what would you all say to him?
That's super cool. We are all really lucky. We got to watch Hail Mary when we were in quarantine. That was a real treat that they sent us a link to view that at home with our families, getting us ready to go on our own space adventure. I would just say to Ryan, you know, it's art imitates science and vice versa, it seems, and he did a great job in that movie, and it's wonderful to see people really leaning into those roles. I thought it was just such an inspirational example. And somebody who goes out there and just gets what was done to save humanity, it's a pretty extraordinary example that we can all follow. We all thought that movie was really uplifting and inspiring.
Hi, Jeremy. This is Harry North with the Montreal Gazette. Congratulations on your voyage so far. What's the camaraderie been like with your fellow American astronauts? Have they teased you much about being the lone Canadian?
There is no way that we are ever teasing this man right here. Jeremy and I have known each other since 2009 when I got selected to NASA and he got selected to the Canadian Space Agency, so we've been great friends ever since. It's impossible not to be good friends with this guy, though. It's just his demeanor, his care for others, the way he goes about life, the way he cares about his family. We might joke around together, but we're not teasing him. And Ike, anything you want to add to that?
You know, similar to our countries physically, this crew is very close, and you know, it's been tough to make fun of him because he got up here, and even though he's Canadian and a first-time flyer, he's making it look easy. He's been doing great so far, so not a whole lot to make fun of.
Lisbeth Cerné, agence Science Presse. Nous savons que vous avez apporté de la nourriture du Québec. J'espère que vous avez commencé à y goûter. En avion, on sait que les papilles gustatives sont différentes, donc on goûte différemment. Est-ce que vous avez déjà commencé à sentir une différence dans ce que vous goûtez? Et j'espère que si ça goûte bon.
Je suis désolé, mais j'ai manqué la dernière partie de cette question. Alors, encore une fois, s'il vous plaît.
Donc, la question, Jérémy, était de savoir si le goût était modifié dans l'espace et si ça goûtait bon au niveau de la nourriture que vous mangez.
Alors, on n'a pas trouvé le sirop d'érable encore. C'est ici, quelque part, mais je ne sais pas exactement où de maintenant. On a, pendant la première journée dans l'espace, on a trouvé des biscuits d'érable. Alors, ça, c'était quelque chose de fun à la fin d'une longue journée. De maintenant, pour moi, ça goûte à peu près la même chose ici dans l'espace. J'ai entendu dire que ça change parce que c'est comme vous avez une grippe dans l'espace à cause de comment la sang bouge dans le corps. Mais pour moi, ça goûte à peu près la même chose. The question was if taste changes in space, and for me so far, I haven't really noticed much change, although I was expecting to notice it more. I don't know. What about you guys? No?
Not on this mission so far.
No.
Jeremy, Sean Costello from Skies Plus magazine and RCAF Today. Question for yourself and Victor, from an aviator's perspective, can you please describe your test flight experience so far, including some spacecraft performance observations or takeaways from when Victor was piloting the ProxOps tests? Thank you.
Well, I have to start off by saying it was a ton of fun. It was a great experience. My favorite thing about the whole evolution was that the entire crew participated. All four of us worked together. And I do love to fly or drive, you know, and operate machinery, and this spacecraft flew marvelously. It was actually in every way better than the simulator. It was, you know, the weightlessness, the sound and feel of the thrusters was very different than what we simulated, and all in a positive direction, and it flies very nice.
Hi, Jeremy, and congratulations to everyone on Artemis II. Jeremy, you've spoken of the importance of the Air Cadet's influence on your young life. Did you know you wanted to be an astronaut when you were an Air Cadet? And now that you are in space, what transferable skills and experience from your time in the cadets have served you in space?
Yeah, I did. When I was joining the cadet program, I'd already set my sights on joining the Royal Canadian Air Force and becoming a fighter pilot. And my dad was the one who told me that he thought the Air Cadets would be a great opportunity if I was interested in flying. And he sure was right. It ended up being one of the greatest decisions that I made, 6 years in the Air Cadet program. I was inspired by images of humans walking on the moon when I was a young Canadian, and that's what encouraged me to kind of follow this path to now. But Air Cadets, transferable skills, there's a lot of them. One of them was, I learned to fly, got a glider pilot license, a private pilot license. That was a huge asset for me. Was building some self-confidence at the age of 16 and 17, but it was much bigger than that. Self-discipline, I learned a lot of that from cadets. It's not all flying and fun. Some of it is marching and parading around, and got to iron your uniform and polish your boots, and so I learned some self-discipline. I learned a lot of confidence because Air Cadets was pushing me outside my comfort zone. There were things that I needed to do, to get these flying scholarships that I didn't really want to do. I didn't want to be on a parade square in charge of a group of other cadets necessarily. I was a little bit shy, and Air Cadets pushed me outside my comfort zone and helped develop that skill set. So I'm really grateful for the cadet program.
Merci, Jeremy, Reed et Victor, c'est Lisa encore. Ça a été une expérience formidable pour nous tous ici à l'Agence spatiale canadienne et en ligne. Auriez-vous un mot de la fin?
Oh oui. Pour moi, comme un Canadien, je suis absolument fier de notre pays. C'était quand je pense de cette expérience et pourquoi je suis ici en représenter le Canada, je suis fier et c'est juste important pour moi de dire merci Canada for cette experience. It has been an extraordinary experience for me to leave our planet, to ride that incredible rocket with my three Canadian colleagues, and my three American colleagues. It is such an extraordinary example of collaboration and what we can do when we set big goals and we reach out to achieve them together. And so on behalf of Canada, I just want to say thank you to my colleagues for this opportunity, and I would like to remind Canadians, if we can send a human around the moon in 2026, just imagine what we're capable of doing next. Thanks so much for joining us on board Integrity. It's a great ship here, and we're closer to the moon today than we are to Earth. This is a big milestone for us, and we look forward to sharing more with you in the coming days. Wishing you all the best. Au revoir.
Thank you all. Bye-bye.
Integrity, this is Houston ACR. That concludes the event. Thank you.
Thank you to all participants. Integrity, we are now resuming operational audio communications. And Integrity Houston, with that, we are ready for the D5 camera at the docking hatch window. And then after that, you can work on dual camera bracket if you'd like.
And Houston, Integrity, the docking hatch windows are already, the images are already complete.
And Integrity, Houston, for the docking hatch window photos, we didn't see you in that area after we had gotten into the attitude, since the attitude maneuver was a little late after the EMER-COM DFTO. So we're just wondering if you could let us know what your target was, what your photo was like for the docking hatch window.
The target was the same Earth I photoed in window 3.
Okay, sounds good. Thanks for just double checking for us. And Integrity, with that, we will, from the ground, send a maneuver back to the Earth in window 2.
Copy, we're ready for that, and I'm ready to take pictures out of window 2.
This is Artemis Mission Control in Houston, Texas. We just saw CSA, or Canadian Space Agency astronaut Jeremy Hansen, complete a public affairs event with various Canadian media outlets. And now the crew is currently working on some D5 camera photos as part of a window optical quality developmental flight test objective.
Houston, Integrity for flywheel accelerometer battery.
We're ready to copy.
Two quick things. First, the battery for the accelerometer on the hull of the vehicle is 55%. And when I downloaded the accelerometer data on the flywheel itself, I think all the data transferred, but I did get a very odd error at the end that just said out-of-memory error on my PCD, but it looked like everything transferred over, so I reinitialized that. If you guys downlink that data tonight, you can let me know tomorrow if it went well.
Reed, we copy both the battery level and the error you got. We'll take a look at that data and make sure we got it all.
And we just heard a call there from NASA astronaut Reed Wiseman, who is working on transferring some data from the flywheel exercise device, specifically data related to an accelerometer. And this is also as NASA astronaut Victor Glover is working through that D5 camera developmental flight test objective related to window optical quality. So he's currently taking images out of different windows on the Orion spacecraft using varying focal lengths of subjects out of the window, such as the Earth or Moon.
Integrity Houston, I bet you already know it, but Earth should be out window 2. Integrity Houston, for a quick end of the day sync, I've got 2 items for you, and we can take any items from you.
Okay, go ahead, Jackie.
Hey, we just wanted to follow up on 2 items. One is related to the hygiene bay odor that you reported earlier. The ground teams do believe it may be related to the orange gasket material around the hygiene bay door. So perhaps it's related to, open and closes of the door or, different operational situations there. But you're welcome to continue to call down your observations and changes in the odor strength or frequency. But overall, we don't have any major concerns. I'm sure some folks will continue to talk about it, but I just wanted to kind of close that topic out. And then second, Christina had a question about Emercom thermal. You made Ink O'Brien smile over here, remembering your training. It is a 60-minute transmission limit with a 45-minute recovery, but it only applies if all of the vehicle cooling is lost.
Okay, we got both of those, and just about the orange insulation around the door of the hygiene bay, we're pretty convinced that's not what we smelled today.
All right, thanks for that data. And Jeremy, just since we're talking about it a little bit, if you want to give us one final set of observations on that smell for today, we would take it.
Yeah, I'm not sure what else we can tell you, Jackie. It was described before as when you turn on, before we flew, what we might expect is when you turn on a heater that's been sitting for a while and you feel that sort of burnt, or you smell that burnt smell that comes from that. And I do think it smelled similar to that. For me, it was, some sort of burning odor. And then it was definitely in the hygiene bay, and when I opened up the hygiene bay, the rest of the crew could smell it pretty much immediately.
We copy, Jeremy, and is that...
Yeah, 2 things out there.
Yeah, we're curious if it is still persisting, and we'll take your 2 things.
That one on the delay. Sorry about that, Jackie. I think 2 things to add from my perspective. Number one, we had a similar smell on flight day 1 when Christina first fired up the toilet, and then we haven't had that at all since. And then this was a more acute moment of this compared to flight day 1. Similar, but definitely more acute.
Okay, we copy, and is it still actively have that odor today, or has it dissipated?
It's been used since, and there was no odor the next time.
Houston copies. That helps. Thanks.
Okay, thanks, Jackie. And window 2 photos are complete. but feel free to leave the Earth in the windows.
Yeah, unfortunately, we've been pretty exploratory in our attitudes today, and we're going to have to head back to something more standard. Let us know if you have anything else to report just on timeline status or things we need to know overnight. Otherwise, that's all we had for you.
Hey, Jackie, Christina here. A couple small things for me. One is I have AGA readings when you're ready.
Go for it.
CO2, 1.5. O2, 19.7. We're at 14.0 psi and 76 degrees Fahrenheit. Also, we have the low battery yellow LED lit. I did not see the bit startup message indicating the level of the low battery. I would propose that we can just maybe wait till next time, see what it is, and then make the decision on changing the battery, if you agree.
Houston concurs.
Copy. And next, the ActiWatch data is on PCD2.
Houston copies.
And last question for you. Are you planning to play wake-up music at the start of post-sleep tomorrow morning?
Affirm, that is the plan.
Okay, great. Yeah, we were just clarifying because in a very nice effort to allow some more sleep, they sort of put that off this morning, but I think we would prefer for it to be at the start of post-sleep.
Yep, we are tracking Christina, and that is our plan.
Appreciate you.
And Jackie, one more thing. I am logging into VC right now for the PMC, but we still want to try charging something off of that PCD4 to see if that actually works or doesn't work. We're waiting for you guys to give us the okay to give that a whirl.
Jeremy, for PCD4, we don't think that the PCD will actually help something charge when it is powered off, but you are certainly welcome to try.
Okay, that sounds good. Makes sense. We just wanted to give it a try. Thank you for that.
And Integrity Houston, sorry, one last question. Can you confirm for us which PCD has some of those great science images you took today? And sorry, specifically images from the window DFTO.
PCD2.
Copy.
This is Artemis Mission Control in Houston, Texas. We just heard quite a bit of chatter between the crew currently on board the Orion spacecraft and the team here in Mission Control Houston, specifically the Capcom or capsule communicator, who you can see on the bottom right-hand corner of your screen. The crew is wrapping up some of their final activities for the day before they head into their pre-sleep and sleep period. So they have wrapped up the optical window imaging developmental flight test objective, where they were taking some images out of the different windows on the Orion spacecraft to test the quality of those images and make any adjustments as needed. They also finished transferring some flywheel accelerometer data. They completed a Deep Space Network emergency communications developmental flight test objective. And they also were transferring and collecting some data related to an actigraph. And that is related to a science investigation on the Artemis II mission known as Archer. And that particular study is measuring astronauts' well-being, activity, sleep patterns, and interactions during the Artemis mission. They are collecting data using those ActiWatches and behavioral or performance surveys before and after the mission, and that actigraphy data is being collected during the mission using those devices, and results from some of this data will be used to understand the effects of space hazards on well-being and performance, and also to develop additional protocols, interventions, and technologies to enable humans to survive and thrive for future deep space missions. The crew is now getting ready to complete their end-of-day private medical conference. This is a standard conference that takes place between the crew and their medical teams on the ground. And then once they complete that, they will have a private conference with the flight director. And the flight director currently on console for Orbit 2 is NASA Flight Director Paul Kanya. And then after that is completed, they will move into their pre-sleep period to get ready for bed.
integrity on 1 for .cam.
Go ahead.
Hey, Jackie, to the best of my knowledge, the docking camera has been installed and powered on. Let me know if you got any issues on the ground.
We copy.
Houston, we are ready for the flight director crew conference if you want to.
We are ready for the conference on 2.
This is Artemis Mission Control. The crew on board the Orion spacecraft, which includes NASA astronauts Reed Wiseman, Victor Glover, and Christina Cook, and CSA or Canadian Space Agency astronaut Jeremy Hansen, are currently wrapping up their day. They are currently in a private conference with the flight director here in Mission Control, which is currently Paul Kanya, who is serving as the Orbit 2 flight director. Following this private conference, they are going to begin their pre-sleep period, and during that period they will perform some hygiene activities and standard cabin configurations to get ready for their sleep, and they will also eat their dinner, and then they will begin their sleep period to wrap up flight day 3. We are currently 2 days, 7 hours, and 38 minutes into the Artemis II mission, following a liftoff from NASA's Kennedy Space Center in Florida on April 1st at 5:35 p.m. Central, 6:35 p.m. Eastern. Today, the crew in the Orion spacecraft did surpass the halfway mark, so they are now closer to the moon than they are to Earth. They are about 142,000 miles away from the Earth and about 131,000 miles away from the moon. This comes following the translunar injection, or TLI burn, which took place yesterday on flight day 2. Today there was a planned outbound trajectory correction burn, but that burn was determined to not be needed, as the TLI burn, which took place yesterday, was very precise and accurate. So the next burn that's scheduled to take place will be on flight day 4, and that will be the outbound trajectory correction 2 burn. That burn is scheduled to take place in about 17 hours and 34 minutes from now.
Integrity Houston, com check after ACU swap. Harriet, I had you loud and clear, I think still on OE2 after the conference. And one item for you, we are not seeing the dock cam. It's showing disconnected. We see the CFC powered, so we'd like you to confirm on PUP1 that the 5-volt power is switched on with green LED for the dock cam.
All right, Jackie, we should be on one now, and that was a great catch. The 5-volt is now on. It was not. Let me know if that worked.
We see it. Thank you. And one final heads up for you, Integrity crew. We are going to be pulling some files from the cab cameras. You may see LEDs indicate that they are on, but we are not streaming from them.
What, you got your fill from the HHP camera today?
No, we all want more.
This is Artemis Mission Control in Houston, Texas. We are currently 2 days, 7 hours, and 55 minutes into the Artemis II mission. Currently on your screen, you are seeing a look at the Artemis Real-Time Orbit website. This visualization provides a look at the real-time data and telemetry coming from the Orion spacecraft when we don't have views of the spacecraft itself. The Orion spacecraft and its crew are currently about 143,000 miles away from the Earth, and they have about 130,000 miles separating them and the Moon. So they are now over halfway to the Moon, and that planned lunar flyby will take place on Flight Day 6, which will be Monday, April 6th. Currently, the crew is in their pre-sleep period, so they're completing some hygiene activities, eating their dinner, and wrapping up the day's activities in preparation for sleep. Throughout the day, the crew completed several different activities. They completed a CPR demonstration, along with several different development flight test objectives, including a flight test objective testing the Deep Space Network emergency communication system. They also did some toilet acoustics measurements, and each of the crew members completed their daily exercise using the flywheel device. Initially, this flight day had a outbound trajectory correction burn scheduled, but that burn was determined it was no longer needed, so that burn did not take place. So the next burn will be the outbound trajectory correction burn on Flight Day 4. Once the crew goes to sleep, that will wrap up most of their activities for Flight Day 3. So then looking ahead to Flight Day 4, the crew will be completing a manual piloting development flight test objective, and during that DFTO, the crew will perform various attitude maneuvers to compare 6 degrees of freedom and 3 degrees of freedom attitude control. 6 degrees of freedom refers to the 6 ways that a spacecraft moves. And there are 3 translational degrees of freedom, which are forward and backward, up and down, and left and right. And then 3 rotational degrees of freedom, which are the roll, pitch, and yaw. So through this DFTO, the crew will compare the standard 6 degrees of freedom to what a degraded quality of 3 degrees of freedom would look like, which means the crew could only control the rotational axes, the roll, pitch, and yaw of the spacecraft. And then following that development flight test objective tomorrow, the crew will also complete a lunar flyby plan review. During that plan review, each crew member will review their lunar targeting package, which is the primary tool guiding crew observations during the lunar flyby on Flight Day 6. It consists of 2 key components, the lunar geography review and the lunar targeting plan. The lunar geography review helps astronauts study major lunar features in advance of the flyby and learn how to orient themselves during the flyby, while the lunar targeting plan provides a detailed timeline of observation targets, background science context, and specific instructions for imaging and verbal descriptions. Also on the timeline for Flight Day 4 will be that orbital trajectory or outbound trajectory correction burn, and that burn is scheduled to take place in a little over 17 hours from now. This is Artemis Mission Control in Houston, Texas. The crew on board the Orion spacecraft is currently in their pre-sleep period to round out Flight Day 3. During this period of time, they are performing some hygiene activities, configuring the cabin for crew sleep, and also eating their dinner. Throughout the day, they completed several different activities, including a CPR demonstration, a Deep Space Network Emergency Communications Development Flight Test objective. They also completed a pre-lunar flyby cabin configuration where they deployed cameras and equipment that will be used during the flyby, and also tested some of the lighting configurations inside the cabin of the Orion spacecraft to make sure that everything was ready to go for the flyby, which will take place on Flight Day 6. They also completed a public affairs event and their daily exercise, which uses the flywheel exercise device. They were originally scheduled to have an outbound trajectory correction burn earlier in the day, but that burn was canceled as it was determined it was no longer needed. So the next burn on the way to the moon will be the outbound trajectory correction burn 2, which is planned for Flight Day 4. In about 16 hours and 49 minutes from now. We are currently in an expected loss of signal with the Orion spacecraft. And we do expect to regain that signal with the spacecraft here shortly. Currently, the Orion spacecraft and its crew are about 144,000 miles away from the Earth, and they have about 129,000 miles separating the spacecraft and the crew from the moon. The crew on board the Orion spacecraft includes NASA astronaut Reed Wiseman, who is serving as the commander for the Artemis II mission. Reed is originally from Baltimore, and he has previously been to space aboard the International Space Station, where he served as a flight engineer for Expedition 41 from May through November of 2014. During that 165-day mission aboard the space station, he completed more than 300 science experiments in areas such as human physiology, medicine, physical science, earth science, and astrophysics. And that expedition also set a milestone for station science by completing a record 82 research hours in a single week. Prior to his assignment to the Artemis II crew, he served as chief of NASA's astronaut office from December 2020 to November 2022. Also currently on board the Orion spacecraft, which the crew named Integrity, is the pilot for the mission, Victor Glover. He was selected as a NASA astronaut in 2013, originally from California. At the time of his selection, he was serving as a legislative fellow in the United States Senate, and his first trip to space was in November 2020 when he launched as pilot of NASA's SpaceX Crew 1 mission. And that was the first operational mission of NASA's Commercial Crew program, which resumed launching American rockets from American soil to the International Space Station. Victor is also a U.S. Navy captain and naval aviator and served as a test pilot, racking up more than 3,500 flight hours. There are 2 mission specialists as part of the Artemis II crew. The first one is NASA astronaut Christina Cook. She's originally from Grand Rapids, Michigan, and was selected to the astronaut corps in 2013. She previously served as a flight engineer on the International Space Station from March 2019 to February 2020, and during that time she set a record for the longest single space flight by a woman with a total of 328 consecutive days in space. She also participated in the first ever all-female spacewalk, and before becoming an astronaut, Christina helped build space science instruments and led scientific fieldwork in some of the most remote environments on the planet. And then rounding it all out is Canadian Space Agency, or CSA, astronaut Jeremy Hansen. He is also serving as a mission specialist for the Artemis II mission. He's originally from London, Ontario, Canada, and was selected as a CSA astronaut in 2009. After his selection, he worked as a CAPCOM, or capsule communicator, at NASA's Mission Control Center in Houston. He has also participated in training exercises such as living on the ocean floor off the coast of Florida to stimulate deep space exploration. And in 2017, he became the first Canadian to lead a NASA astronaut class. And this is Jeremy's first trip to space. Again, those 4 crew members currently on board the Orion spacecraft, which they named Integrity. They launched aboard the Orion spacecraft atop a Space Launch System, or SLS, rocket from NASA's Kennedy Space Center in Florida on Wednesday, April 1st at 5:35 p.m. Central, 6:35 p.m. Eastern. Today, they surpassed the milestone, making their distance closer to the moon than from Earth. And currently, they are on board the Orion spacecraft preparing to go to sleep and round out Flight Day 3. And now on your screen, you're seeing a view of the Artemis Real-Time Orbit website, or ARO, and that website's available at nasa.gov/trackartemis. It provides real-time data and telemetry updates from the Orion spacecraft, especially when we don't have those live views coming from the cameras on board the Orion spacecraft itself. This is Artemis Mission Control here in the White Flight Control Room at NASA's Johnson Space Center in Houston, Texas. Joining me on console as part of the Orbit 2 team is Capcom, or Capsule Communicator, Jackie Mahaffey. She also serves as the Artemis II Chief Training Officer, so she's going to join us for a few minutes and answer some questions while the crew works through their pre-sleep period and then gets ready to get some rest. So Jackie, first off, can you tell us about your role for the Artemis II mission?
Yeah, sure. So pre-flight, my role as the Chief Training Officer was to lead the team that prepared the crew for everything they need to do during the mission. And now that the mission has started, I also have the pleasure of being a Capcom and getting to work with the team to get messages up to the crew and hear what the crew has to tell us.
We got to hear you a lot during this shift, calling up to the crew while they were working through some of their tasks. So looking towards your role before the mission, so what did some of that training that you worked with the crew, what did that consist of?
Yeah, so really we have to prepare the crew for all the different things they might have to do on the mission. So that includes everything that we've planned, from launch through the lunar flyby all the way back to splashing down in the Pacific Ocean. And then, of course, we want to prepare them for any potential contingencies that might come up. So we exercise those off-nominal situations as well.
All right, and they were training for a couple of years in preparation for this mission, so I'm sure you got to work pretty closely with them and develop some relationships with them along the way. Did you have any favorite parts of that process?
You know, what was really cool about the process of coming up with training for the first time and delivering a set of training for the first time was we were collaborating together with the crew on how exactly were they going to do these tasks. And so we would, we might develop a lesson or a simulation scenario, but then it was always followed up with a discussion of, hey, what did we learn and what do we go change and make better, and what ideas do we have collectively to enable the crew to make the mission a success.
All right, and now that the mission's underway, we're on Flight J3, or rounding out Flight J3. What's it like serving as a Capcom or Capsule Communicator for the mission?
Yeah, so I was able to sit in mission control for the launch, but I was not the active Capcom at the time, and so tonight has been my first shift getting to talk directly with the crew, and it's been really amazing to finally get to guide them in the real thing and work with them and help them work through issues or answer questions from the ground and get them through their whole timeline for the day.
It's so exciting. And so you kind of have a dual role. You had your pre-mission role and now you're during the mission Capcom role. How do you balance those roles, being the training lead and also now being a Capcom for the mission?
Yeah, it was actually a really, I guess, sort of complementary set of roles, because as the being on the training side, I was able to either be a part of all of the training that the crew has, or observe that the training they're doing and the feedback that they are giving and the conversations that they're having about how they plan to do things. And so, coming in here and supporting them for the mission itself, I just feel really comfortable with the systems and the procedures and maybe have a little glimpse into what they might be thinking when they make a call.
That's so exciting. I'm sure the relationship you developed certainly plays a role in that. So I don't want to keep you too long. I know you actually have a job to get back to, especially coming out of a loss of signal here shortly. But what are you most looking forward to during the remainder of the mission?
Well, I think the thing that hit me the most so far was getting to see the video of them in integrity, and it looks in some ways really close to what it looked like when they were training in our mock-up here at Johnson Space Center, and then in other ways, it's zero gravity and they're floating in it, and it clearly is in space and on the way to the moon. So I am looking forward to more of that, more of those insights into them being in the capsule, and then also some more of the photos that they are sending down, which are just incredible.
We have certainly had some incredible photos, and we're now well on our way to the moon, over halfway, 128,000 miles to the moon and 146,000 miles from Earth. But with that, thank you so much, Jackie, for joining me, and we look forward to the rest of the mission. Thanks for having me. This is Artemis Mission Control in Houston, Texas, as the Artemis II mission around the moon continues. We are now 2 days, 9 hours, and 20 minutes into the mission, following a liftoff on April 1st, and the Orion spacecraft is about 147,000 miles away from Earth and about 127,000 miles away from the moon. The crew is currently preparing to go to sleep to wrap up their third flight day of the mission. Currently on your screen, you can see a view of Earth taken by NASA astronaut and Artemis II Commander Reed Wiseman from one of the Orion spacecraft's 4 windows after completing the translunar injection burn on April 2nd. And that TLI burn is what set up the crew to send them around the moon and back as part of a free return trajectory. This particular image showed the Terminator line, and now on your screen you can see another one of the images that was captured by the crew. This view was taken also by NASA astronaut Reed Wiseman, and it shows one of the Orion spacecraft's 4 main windows with a view of Earth peeking through that window. And that Orion spacecraft, of course, is named Integrity, and it was named Integrity by its crew. And this image was also captured following the translunar injection burn. Now on your screen is another view of the Earth, the Orion spacecraft looking back at Earth following that translunar injection burn on April 2nd. It shows the Earth fully illuminated by the moon itself. It's actually the dark side of the Earth when this image was captured, but the moon was illuminating it from behind. The crew continues to capture imagery every day and continues to downlink that imagery, and we continue to review and upload and share with the world as often as we can, and we plan to do so for the duration of the mission. And of course, as we get closer to the moon, we'll be able to share some additional images of the moon from a closer distance. We do expect that lunar close approach and the lunar flyby observation period to take place on flight day 6, which will be Monday, April 6th. Today, the Orion spacecraft surpassed the halfway mark, so then they are now officially closer to the moon than they are to Earth. Lunar sphere of influence until Sunday, April 5th. And once they enter the lunar sphere of influence, that is when the moon's gravity will be exerting more force on the Orion spacecraft than the Earth's gravity. The Artemis II mission is the first crewed test flight as part of the Artemis program. So it is the first time that humans are living and working aboard the Orion spacecraft. The quartet of crew members that are currently on board the Orion spacecraft include NASA astronaut Reed Wiseman, who is serving as the commander. There's also NASA astronaut Victor Glover serving as the pilot, and NASA astronaut Christina Cook serving as a mission specialist alongside CSA, or Canadian Space Agency astronaut Jeremy Hansen. Again, the crew is currently completing their pre-sleep period, and then in just a few minutes they will head into their sleep period. And during this pre-sleep time is when they complete some hygiene activities. It's also when they eat dinner and wrap up any remaining activities for the day. Coming up tomorrow on flight day 4, the crew is expected to have an outbound trajectory correction burn. There was initially going to be an outbound trajectory correction burn today on flight day 3. That outbound trajectory correction burn ended up being canceled because it was determined that it was no longer needed, as the TLI, or translunar injection burn, on flight day 2 was very accurate, so the correction was not needed to adjust the orbital trajectory on its way to the moon. If that outbound trajectory correction burn ends up being needed, that burn would take place in about 15 hours and 50 minutes from now. Also taking place on flight day 4 will be a manual piloting developmental flight test objective. During that test objective, the crew will perform several attitude maneuvers to compare 6 degrees of freedom and 3 degrees of freedom attitude control. 6 degrees of freedom refers to the 6 ways that a spacecraft moves. There are 3 translational degrees of freedom, which are forward, backward, up and down, and left and right. And then 3 rotational degrees of freedom, which are roll, pitch, and yaw. So through this objective, the crew will compare the standard 6 degrees of freedom to the degraded qualities of a 3 degrees of freedom, which would mean the crew could only control the rotational axes of roll, pitch, and yaw.
Integrity Houston, late call related to toilet.
Go ahead.
Sorry to interrupt, but we would like to take this timelined wastewater tank dump in just a couple of minutes. If we are successful, then we can clear you for toilet for the rest of the night with confidence.
Jackie, we are all now getting into sleeping bags, and we are finished with toilet for the next little bit, so go for it.
Okay, and would you like a negative reporting? If it's good and you are go for toilet for the rest of the night, we will not call you back. If there is some trouble with it and we need you to coordinate toilet use or use CCUs, then we can give you a second call.
Yep, 100% negative reporting. Thanks.
Will do. Good night.
Good night, Houston.
This is Artemis Mission Control. We just heard some communication there from the crew on board the Orion spacecraft named Integrity.
Confusion on board. What's a good MET for when we would be go for toilet with negative reporting?
Let's go with MET of 10 hours.
Okay, we copy. Thanks.
This is Artemis Mission Control. We just heard some communication with the Artemis II crew currently on board the Orion spacecraft named Integrity, and the team here on the ground, specifically the Capcom or capsule communicator, Jackie Mahaffey. And on your screen you can see a live look into the Artemis flight control room here in Mission Control. Currently on console is the Orbit 2 team of flight controllers, and they will be wrapping up their shift in the next hour and a half or so. We do expect that Orbit 3 team of flight controllers to come on console to begin a handover period in about 30 minutes. But during that call down, the crew was discussing an upcoming wastewater dump, and basically that is when the stored urine on board the Orion spacecraft is vented overboard, and this takes place every day by the crew, similar to the space shuttle. And the crew is now also entering into their sleep period. So they will be in their sleep period for about the next 9 hours or so.
Integrity Houston, for wastewater dump. It was no joy. You are no-go for toilet, and we'd like you to use CCUs overnight. We would like you to hold the CCU dumps until the morning, unless you must dump in order to have ullage in the CCU. In that case, it's acceptable.
We copy. And Jackie, can you remind us of CCU storage location?
Checking.
And you can disregard. Christina's got it.
This is Artemis Mission Control in Houston, Texas. We just heard some communication between the crew on board the Orion spacecraft and the Capcom or capsule communicator here in Mission Control. They were discussing a recent wastewater dump. The space toilet on board the Orion spacecraft is called the Universal Waste Management System. And as part of this system, the urine is stored in a tank and then vented overboard each day by the crew. A few minutes ago, the crew was completing that overboard venting or that wastewater dump, and it does sound like there was a bit of an issue there, so that's being troubleshot. But in the meantime, the crew will enter into their sleep period and use the contingency collapsible urinals as needed overnight while they continue to troubleshoot the wastewater dump. And currently here in Mission Control Houston, the Orbit 2 team of flight controllers is starting to wrap up their shift. So the Orbit 3 team of flight controllers is starting to come on console and complete that handover period. The Orbit 2 team has been led by NASA Flight Director Paul Kanya, and the Capcom or capsule communicator has been Jackie Mahaffey. Currently, the Orion spacecraft is about 148,000 miles away from the Earth and about 126,000 miles away from the moon. Currently on your screen, on the upper left-hand side, you can see a view from the Artemis Real-Time Orbit website, or ARO. This provides real-time data and telemetry updates when we don't have those live views from the Orion spacecraft itself. And in the bottom right-hand corner of your screen, you can see a live look inside the Artemis flight control room here in Mission Control. This is Artemis Mission Control in Houston, Texas. The crew on board the Orion spacecraft, named Integrity, is currently in their sleep period. The sleep period will last for about 8.5 hours before they will be awoken to begin Flight Day 4. And here in Mission Control Houston, the Orbit 3 team of flight controllers is coming on console to begin their shift, and they are completing a handover with the off-going Orbit 2 team of flight controllers, which was led by Flight Director Paul Kanya. And currently on your screen, you can see a view of the Artemis real-time orbit website, or ARROW, which is providing live data and telemetry updates of the Orion spacecraft as it makes its way to the moon. The Orion spacecraft and its crew are currently about 149,000 miles away from Earth, and they are about 125,000 miles away from the moon as they continue to make their outbound journey to the moon on that free return trajectory. They are scheduled to make the lunar close approach and their lunar flyby on Flight Day 6, which will be Monday, April 6th. Coming up on Flight Day 4, there is a planned outbound trajectory correction burn. There was initially going to be a first outbound trajectory correction burn today on Flight Day 3, but that ended up being canceled as it was determined that it was no longer needed due to the accuracy of the translunar injection burn, or TLI burn, which took place on Flight Day 2 to begin sending Orion and its crew outbound and around the moon on that free return trajectory. As the Orbit 3 team of flight controllers completes their handover, I will also be handing over our live continuous coverage of the Artemis II mission to my colleague Nilofer Ramji, who will continue providing updates of Orion and its crew over the next several hours. With that, this is Mission Control Houston.
Good morning from Mission Control Houston inside the Artemis Flight Control Room here at the Johnson Space Center. We are at a mission elapsed time of 2 days, 11 hours, 6 minutes and counting. I'm Nilofer Ramji with NASA Communications. The Orbit 3 team of flight controllers has recently come on console and have completed their handover with the Orbit 2 team who just completed their shift. The Orion spacecraft is currently further away from the Earth than it is from the Moon. We are about 151,000 miles and counting away from the Earth and 124,000 miles to the Moon. The Artemis II astronauts are currently asleep aboard the Orion spacecraft named Integrity. Their sleep shift began approximately at 2 days, 9 hours, and 30 minutes, and it'll last about 2 days and 18 hours. We will continue to stand by with our live 24/7 coverage. For now, this is Mission Control Houston.